Hi all, good morning, good evening, good afternoon, wherever you are. A warm welcome to this session. I hope you all are doing well. Please ignore the tone of my voice. My voice is not very well this morning, but I would request you to focus on what I am telling or the content I would like to say. Please focus on that. And today, what we're going to do is nothing but intro to exercise 1.2. In the previous session, we discussed about exercise 1.1. I hope you've gone through it and you've understood the concepts. If you have any doubts or you did not understand any thing, just let me know. And anyways, we will be practicing some extra questions as well at the end of the chapter. So during that time, I'm sure we will go through a lot of training and I'm sure your concepts will be strengthened. So, let me just give you a key summary of what are the topics we will cover in this session. So, firstly, we will be covering what is irrational number or what is an irrational number, what are real numbers, and how do you represent real numbers on a number line. These are the adequate concepts which are required for exercise 1.2. So, let's start, guys. So we had learned what is a rational number. Now you tell me what is a rational number. Come on, I know you can do it. Hey, don't tell me you can't do it. Huh? I'm sure if you went through the previous one, previous introductions and all of that, you would have understood it. Yes, rational numbers are those numbers which can be expressed in the form of p by q, where p and q. Oops, okay. Um, yeah, where p and q are integers and q does not equal to 0, right? Now, what are irrational numbers? What are irrational numbers? Very simple, no? Numbers which are not rational are called irrational numbers. Absolutely. So, in other words, I can say in the definition format, a number, a number which cannot, the key word here is cannot. The number which cannot be expressed expressed in the form of p by q, where of course the same line which we wrote here, where p and q are integers integers and q does not equal to 0. So, as we discussed, numbers which are not rational are called irrational numbers. Let's have some examples to see this. So, if I take a number root 2, root 3, root 5, pi is also an irrational number, okay? How can I say that it is an irrational number? How are you saying this, Esther? If that is your question, let me just explain that, but hold on, let's complete with this. I will explain that next. Okay, so these are some examples of irrational numbers. I will give you another one bonus, you can say. 0.160, 1600, 16000, and all of this. How is it decimal expansion, or what is the decimal expansion have to do with the irrational number and all of that? Okay, we will also discuss about decimal expansion, but not in this session. You will understand how this example is an irrational number in the coming sessions. Maybe I think after exercise 1.2, it will be definitely clear, I'm sure. Okay, we will go for an intro to exercise 1.3. That time I will teach you what is that. So for as of now, you just keep this in mind. A very easy example is root 2, root 3, root 5, and of course pi. Okay, coming to the value of pi, how is pi an irrational number? If that's what you say is your question, let me tell you. See, usually while solving sums like suppose a circumference of a circle or area of a circle, what do we write? We write 2 pi r, and for area we write pi r square respectively, right? So here you're seeing there is a value called pi, here also a value called pi. And we know that according to the question, or many times in the question itself, they will say pi value is equal to 22 by 7, or pi value is equal to 3.14. Let me just give you the exact, decimal expansion of this 3.14. Okay, so the exact decimal expansion is 3.141592653589, and so on. You can refer page number 13 of NCRT textbook chapter 1. Okay, if you have a textbook, check that out. Or else if there is a PDF also, I think the page number will be mentioned. You can go through that as well. So if you see, there's a statement, what about the famous irrationals root 2 and pi? Here are the decimal expansions up to a certain stage. Ignore root 2, pi we'll take. There is 3.1415926535897933, blah blah blah, and it keeps going on, and all the digits are not recurring. I mean, it doesn't come in a recurring order like 141414 or 230 3030. It doesn't recur like all of this, right? So that's what I mean by saying like recurring. Okay, so uh, there is another note given there, that we often take 22 by 7 as, this is a highlighted word, I would say, approximate, as approximate value for pi. But pi is not equal to 22 by 7. That means what? We are taking this as an approximate value, but that doesn't mean that pi is equal to this. So, of course, thereby I can say pi is not a rational number. Clear? See, if you look at the decimal expansion, this is a non-dominating, non-recurring. Now that is again going to a little bit confuse you. So I will explain this decimal expansion and we come to introduction of exercise 1.3. That time again I will explain the pi thing, and that time I'm sure you will understand this. Clear? Just for clarification sake, I did this, but we will talk about this in the next session. Okay, so now let us go and move on to the next part. The next topic is nothing but real numbers. What are real numbers? In simple words, real numbers consist of rational as well as irrational numbers. So that means that real numbers are a collection of rational and irrational numbers. Always keep this in your mind. Real numbers consist of rational as well as irrational numbers. It is a set, it is a collection of these two. So this is nothing but real numbers. So real, rational numbers are what? Again, 22 by 7, 15 by 4, etc. Irrational numbers root 2, root 3, pi, and all of that. Okay, so this is what is real numbers. Easy? Easy concept, no? I feel it is very easy. So moving on, now we have the next topic as representing real numbers. Okay, I'm sorry for my handwriting, it's not coming out very well today morning. I don't know what's happening. But I'm trying my best to write as neat as possible. So let me just write it once more. As discussed before, real numbers are nothing but, nothing but what, Pa? Nothing but rational and irrational numbers. So, firstly, we will learn how to represent some rational numbers on the number line. Then we will move on to irrational numbers. Actually speaking, in your textbook, right? If you see exercise 1.2, we have only a sum to represent root 5. Okay, but I will teach you how to do rational numbers as well. Because sometimes it could come. I really don't know about the papers because, well, I don't keep the papers and I'm also a student like you all. I'm not a teacher or anything. But from my side, I love to help people out and I love to use my talents in order to benefit others. So that's what I'm doing right now. So don't ask me about the question paper. I don't know how it all works, but maybe I have no idea. I'm saying it could come, but mostly maybe we would get irrational numbers. Okay, but again I'm telling you, don't trust me on the question paper part because I don't know about that. Okay, let's move on. So firstly we will learn how to represent rational numbers on the number line. Okay, so rational numbers on the number line. Right, so let's start with an example. So I'm not going to write down the whole question, but I'm just going to write the number which we have to represent. So the question goes like, represent 2 by 3 on a number line. Again, I repeat, represent 2 by 3 on the number line. Okay, so that means what we have to do now, we need to represent 2 by 3 on a number line. We know what is a number line, right? So let me just draw a number line for you. I think I will try using a line or something and let's see. Hopefully this works. Okay, so yeah. Okay, this is working. So firstly, we are going to measure like 1 unit. Okay, and now I'm telling you what you should do. I am not able to measure 1 unit on a screen, you know that, right? So I'm telling you the instructions which you need to do in your notebook. By the way, whatever we are learning here, I want you to make notes of that, especially like all the definitions, everything which we are doing. Okay, just make a note of all of these because it is very, very important. Okay, so now take your scale, draw a straight line, no measurements, just draw a straight line and draw two arrows on either ends. And then start by start by writing a line, a vertical small line, -2. Now measure 1 unit, 1 unit, and write -1. Similarly, here as well, 1 unit, 0. 1 unit, again you will have 1. And now what I want you to do is just leave some gap. I mean to say, just 1 minute, I will erase this one. Okay, just do up till 0. I will tell you what you have to do next. Okay, just do up till 0 for now. It is fine. So next step is, how will we represent this on the number line? So, firstly, what you need to do is understand between which two numbers does 2 by 3 come. An easy way to find that out is by dividing 2 by 3. So, when I do this, I will get what 3 6 are 18. So, again, so 0.6. This will keep going on 666 and will keep going on. That's a different story, but the whole number is basically 0.6 here. So between which two numbers does 0.6 come on the number line? Between 0 and 1? So that means now what you need to do is leave a big gap between from zero, starting from zero, leave a big gap and write 1 here. I'll tell you why. Then what you need to do is the very next thing is, since you have understood that between 0 and 1 we've got 0.6, you need to make divisions according to the number in the denominator. Now you see 3 here, that means we will have 3 divisions. So we'll have 1, which will give us 1 by 3. Second division, 2 by 3. If I make the third division, which is nothing but 3 by 3, when I cancel, I will get 1, no? So that means this 1 will come. So how do you know that you made the right divisions? By looking at the space. If you see, we have 1, 2, 3. So your number in the denominator will tell you how many divisions are there that you have to make and how many spaces you have to leave. Are you getting my point? See, I will explain it in proper words next. Firstly, through this sum, let me just tell you how to do it, and then I will tell you in proper words, in proper key points, so that you will understand. Firstly, what you need to do, construct a number line by drawing a line, two arrows on both sides, and then leave 1 unit gap between these between each number. So -2, -1, 0. And now, depending upon the question, you need to analyze between which two numbers the rational number is coming. So here we have 2 by 3. 2 by 3 will come in between which two numbers? To check that, we are going to be dividing as we told. And we got 0.6. So between which two numbers is 0.6? 0 and 1, right? So we are going to now put 2 by 3 between 0 and 1. How are we going to do that? By looking at the denominator, we know that there are 3 divisions. And how do you know that you have constructed 3 divisions? By looking at the space between this number and this division and this division, we have one space. Between this and this, we have another space. Between this and this, we have another space. So we have 3 spaces. That helps us to know that there are 3 divisions. Now, as you see, we have got our 2 by 3 here, right? Over. Easy. Is it? Did you understand? I hope it's understandable. Let's do another example so that you will understand it better. So this is number 2. Our previous one is number 1, of course. So the second question is, represent 12 by 3 on the number line. 12 by 3, how you'll do? Here only you can simplify. Very easy, guys. This is very, very easy. 12 by 3, when you simplify, 3 ones are 3, 3 fours are 12. You will get your answer as 4. So you know where to represent 4 on the number line. No? I don't need to tell you, right? Of course. So now we will draw a line. Not such a big line. I think this is enough. Yeah. So now, next, -2, -1, of course, are 1 unit. It needs, the division needs to have the specific measurement. So 1 unit is the best. So 1, then 2, then 3, and 4. And of course, here we have 4. So we have represented it. Easy, right? So you need to check the rational number if it is further, possible to simplify it. And then in the simplest form, you need to represent it. Okay? I hope it is clear now. Now, so far, what we have done is we have represented proper fractions. You know what are proper fractions? The numerator is lesser than the denominator. We have represented such numbers in the number line. But you can say that 12 by 3 is an improper fraction. No? How did we do that? 12 by 3, we simplified it to what? We simplified it to 4, a number. So therefore, we were able to do that as a proper number on the number line. But now what we are going to see is actually an improper fraction which cannot be simplified. How are we going to solve that? So the number is, represent 7 by 3 on a number line. So how do you represent 7 by 3 on a number line, guys? So the very first thing which you have to do is, of course, construct a number line But before doing that, we will do one more thing. We need to convert. Always remember, when you have an improper fraction, if it is not possible to simplify it, I'm saying in such cases, what you need to do is convert it to an improper fraction. So how will you convert it? 3 3 divided by 7. I think I'm telling the wrong statement, sorry. 3 divide 7, yes. So now what you will get? 2, 6, and then 1 you will get. So 1 is your remainder. You know how to convert improper fractions to mixed fractions, right? So quotient, remainder, divisor. Quotient, remainder by divisor. That's how you write a improper fraction. So 2, 1 by 3. Now how do we do this? See, as I told you, always improper fractions must be converted to mixed fractions. So now we have a number 2 here, and next to that we have 1 by 3. So this shows that 1 by 3 will come after 2. Are you understanding? After this number 2, this 1 by 3 will be coming. So now we need to make the appropriate partitions by looking at the denominator. So now we need to construct a line. See, when we have improper fractions, right, we need to convert it to mixed fractions, and after that, by looking at this number here, we can say after which number is the this fraction which is coming after 2 going to come. Clear? So now minus 2, let's not do minus 2 this time. I am going to just write minus 1, that's enough. Minus 1, 0, 1, 2, and then 3. Now as usual, look at the this denominator, look at this number 3, and then we will put 3 divisions. So you will have, you should need to you need sorry you need to write it like 2 1 by 3, because that's our number here. So 2 1 by 3, first space, second space, 2 2 by 3, and then we have our third space, first space, second space, and then our third space. Okay, so now we've got our number 2 1 by 3 on the number line. I hope it is clear. If you want more sums, just let me know. I will try to help you out as much as possible. So we've got 2 1 by 3 on the number line. So this is not very important, I would say. The main thing is irrational numbers on the number line, which we will learn now how to do it. Okay. So before that, let us solve another improper fraction to mixed fraction, that question. Okay. Actually, in this question, we will not be converting directly. You have to do so. Represent 3 1 by 5 on a number line. If you see, we will have a number line, of course. Okay, a number line we have now. Minus 1, 0, 1, 2, and I told you, how do we know where is this coming on the number line? Look at this number. So that means after 3 it will come. So 3, and of course our denominator of this fraction tells us that there are going to be 5 divisions. So I'll solve this in a different ink for you. This will be 3 1 by 5. Okay, I think I have to reduce the thickness of the pen because we have to write so many numbers there. Just a second. Okay, I can't further reduce it. Okay, let me try extending the line. That would be better. Okay, I'm not able to click it. Okay, I will draw a new number line, and in that we will solve. Okay, so Really sorry, guys, for this technical problem. Yeah, so completely ignore this previous line. So now, as we said, we will put -1, 0, 1, 2, 3, and 4. Now we have a very big space, huh? So now we need to put 3 1 by 5 on the number line. The first space, 3 1 by 5, 3 2 by 5, 3 3 by 5, 3 4 by 5. If I do 3 5 by 5, that won't be possible. I mean, we shouldn't do that because we already have 5 spaces. So 1 2 3 4. Okay, just a second. And 5. Yes. So 1, 2, 3, 4, 5. We have 5 spaces. So thereby now we can just circle this one, 3 1 by 5, and tada, we have our 3 1 by 5 on the number line. Easy. I hope you understood so far. Huh? So these are rational numbers. Now we're still not done with real numbers yet, because real numbers consist of rational as well as irrational numbers. So now only we are going to irrational numbers. Clear? Now, nextly, we are going to learn about irrational numbers on the number line. Irrational numbers on the number line. How do you represent irrational numbers on the number line? For this, I need you to go get your geometry box income. Geometry box must have your everything which is required, like the compass, the pencil, protractor, everything. Okay, so please bring that and get back here. So, firstly, we will start by representing root 2 on the number line. Root 2 on a number line. Okay, so we will not start with root 1, we will start with root 2 basically. So how do we do that? Now this is very very important, guys. Very important, very important. Pay attention. Okay, firstly, draw a line. Secondly, write the numbers -1, 0, 1. Sorry, I'm writing 2 instead of 1. Great. So 1, 2. 2 is enough. Till 2 it's fine. You leave the space, whatever, or you construct accordingly. And obviously this must be, all these spaces must be 1 unit gap. Understand? Should be 1 unit. All the units which you are putting, like -1, -2, 0, 1, 2, 3, 4, everything. Okay, clear? So next, the very next step is specify that between 0 and 1, consider the numbers 0 and 1. Okay, so consider the numbers 0 and 1 and write 1 unit. Let's say that this point 0 is A and this point 1 is B. Clear? So AB is equal to 1 unit. Clear? Now what you need to do, take your scale and from point B measure 1 unit. From point B measure 1 unit. Okay, or what you can do is take your scale and just draw a straight line from point B. Then take your compass and measure 1 unit on the scale. You know how to measure 1 unit using the compass? Yes, I hope you know that. Then from keeping your compass on point B, cut an arc here. Okay, sorry, I didn't know it'll get that effect. Yeah, so cut an arc here. Cut an arc. So that means what, this should be 1 unit. I'll tell you why are we doing this, what is the reason and all of that. But firstly, Just follow my steps here. So let's name this point as C. So BC is again equal to 1 unit. Now join point C to point A using your scale, of course. So this will give you a sort of right angle triangle, right? So now what you need to do is measure AC, measure AC, and then keep your, measure AC using the compass, sorry, and keep your compass on point B and start cutting an arc. So keep your compass on point B and start by cutting an arc like this. So from here, probably your compass arc or your arc, whatever you draw, should be at least like 1.5, or it should come close to half of, half of like 1 and 2, like it should be in the middle. Hopefully it should be like that. So this is nothing but root 2. So your hypotenuse is nothing but root 2. Now what is all of this? How is this equal to root 2? So many questions popping up in your head. Let me explain. See, now we need to represent root 2 on the number line. So we will be using Pythagoras theorem. Pythagoras theorem. So by Pythagoras theorem, that is nothing but AB square plus BC square is equal to AC square according to this figure. I am saying the units. So that's nothing but AB is what? 1 square plus BC is what? 1 square plus AC is what? Root 2. That's what we want. Root 2 the whole square. 1 square is nothing but 1 plus 1 square is again 1, which equals to uh, okay, sorry, I'm just so sorry. um, So by Pythagoras theorem, we will be solving this as we told, AB the whole square plus BC the whole square is equal to AC the whole square. So can I write that hypotenuse square, AC square is nothing but hypotenuse square, is equal to base square plus altitude square. Altitude is nothing but height square. So firstly, I bring this square to this side. So this will be root of base square plus altitude square. Base square plus altitude square, which is equal to your hypotenuse will be nothing but root 2, which equals to root of, on the RHS basically, on the root of base is 1 square plus altitude is also 1 square. 1 square is nothing but 1. 1 plus 1 will give you nothing but 2. So therefore, it will be root 2. That's how we get our hypotenuse now. Okay, so I just exclude the part where I wrote root 2 here. But to get our hypotenuse, how we will calculate base square plus altitude square? That's how I got root 2. And that's exactly what I need, because I need to represent root 2 on the number line, right? So once I measure root 2 on the number line, on this right angle triangle, so AC will be equal to root 2. Then I'm measuring AC, I'm measuring the root 2, and by placing my compass at B, I'm representing root 2 on the number line. Clear? Is it clear? I hope it is. So similarly, we will do root 3 also. So we have root 3, root 4, root 5. I think up to root 5 it's enough. If you understand how to do root 2, root 3, root 4, other roots and all, easily you will do. So let us then discuss now about the next one, root 3. So to do root 3 on the number line, what we will do is just first construct root 2 again. Okay, root 2 again for practice sake as well as for root 3 sake. So take your scale and just draw a line. I'm explaining the steps again. I'm so sorry if that Pythagoras theorem thing was confusing, but this time I will try my best to explain it as clear as possible. Then minus 2, 1, minus 1, 0, 1, 2. This should measure 1 unit. 0, we will consider this point as A, this point as B. AB is equal to 1 unit. Now draw a line from B using your scale, measure 1 unit using your compass and cut an arc. This point is C. So BC is equal to 1 unit. Now join AC. So this will give you nothing but a right angle triangle. It looks like one. So what am I trying to do? Using the Pythagoras theorem. By Pythagoras theorem, by Pythagoras theorem, I'm so sorry guys, I'm so sorry for the errors. By Pythagoras theorem, what is Pythagoras theorem? Hypotenuse is equal to root of base square plus altitude square. So this is equal to root of base is 1 square plus altitude is 1 square, which equals to root of 1 plus 1, which equals to root 2. That's how I got my hypotenuse as root 2. Now is it clear? I think the last time I confused you. I'm so sorry. It just didn't come out properly. So yeah. Now the next thing is we've got our root 2. Now how do we do root 3? That is our main point now. So this is root 2 we got, root 2. Now we are going to use this itself as our base. So that means we will construct root 3 using root 2 itself on this number line. Using this place itself, we are going to construct root 3. How? You will consider root 2 as your base. Root 2 is your base. Okay? Or that means AC is your base. Now, keeping this as your point, using a protractor, measure 90 degrees. Okay, measure 90 degrees using the protractor by keeping it like at point C. Okay, you know how to use a protractor, right? And that middle point should be on C. So then you should get 90 degrees. Now, let's say this is a point D. Now join DC. It should be a straight line. I know mine is crooked, but really sorry for that. I will just try to make it straight for you. Okay, so now we've got a straight line DC. So this is nothing but 90 degrees. Now using your compass, cut 1 unit, measure 1 unit and cut an arc here. This is point E. Now join E to A. Of course, again using your scale. So this is nothing but AE. Now AE is nothing but root 3. Do you understand? Using our root 2 as our base, I'm telling you, go through this method. This will be very easy for you and you will get accurate results as well. This is how even I've done it at school, and that's how our teachers have taught us too. Okay, root 2 is your base. Construct 1 unit. Okay, let me tell you all the steps from the beginning. Consider root 2 as your base, which is nothing but AC, and then using a protractor measure 90 degrees from point C, then cut an arc of measuring 1 unit using your compass from point C, which will give you point E. Then join AE using a scale, which is nothing but root 3. Again, for this also we have Pythagoras theorem. Pythagoras theorem, I will explain that. But uh, this is root 3. Now root 3 must come on the number line. No? How we will do that? So for that you need to take the measurement of AE using your compass. So AE using your compass, and then from point A cut an arc. It should probably come like I think almost next to 2. Okay, if you cut an arc, it should come almost next to 2. I'm not drawing it properly, that's why it's not coming. But when you do it, it should almost come like next to 2. Ignore my arc, but your book should have something like that, like how I told you, it should come almost next to 2. So this is nothing but root 3 on your number line. Let's now see the Pythagoras theorem for root 3. Pythagoras theorem for root 3. So again, hypotenuse is equal to root of base square plus altitude square, which is equal to root of base square plus altitude square. What is your base now? Root 2 the whole square plus altitude is what? 1 square. We saw here, no? Root 2 is your base, height is 1. So this will be root of, always remember, if there is a root number, any root number which is squared, the root and the square will be cancelled. So you will get nothing but this inside number. Any number which is having root, if it is squared. So root 7 squared also, this will be like cut, you will get 7. Root 6 square, root 6 square, it'll get cancelled, give you 6. Always remember, this will be carried out throughout mathematics, always. In chapter 2 polynomials also it will be carried on. Okay, we will see a lot of that being used there. So now let's get back here. Root 2 square, root and square will be cancelled to give us root. 2 plus 1 square is 1. So 2 plus 1 is 3. Hypotenuse is equal to root 3. That's how we got root 3. Is it clear, guys? Let me explain once more. By using Pythagoras theorem, we are getting this. Base is root 2, 90 degrees at point C, and then 1 unit measurement. There should be a arc cut of 1 unit using compass. Join that point AE to point A here to get root 3 as your hypotenuse. So a lot of lines I know, like it was just like too much. Okay, so I think I shouldn't have erased it. So I felt it looked a little congested. Anyways, so yeah, basically this is how you do it. Okay, clear? I hope root 2 and root 3 is clear. If it is not clear, just let me know. Anyways, when we start 1.2 exercise, question number 3 tells us that we need to we need to express root 5 on the number line. So that time we will again go through this, and we will also learn how to represent root 4 and root 5. So meet you all in the next video, starting with exercise 1.2. Thank you guys so much for being patient and listening to this recording and this session. I hope you found it beneficial, and I hope the concepts were clear too. Have a good day ahead. God bless you. Bye bye.